In this lesson, we're going to look at how to simplify radical expressions that are being divided. Up until this point, we've only worked with multiplication here. So let's take a look at the division property of radicals. If you have two radicals being divided and their indices are the same, both of their indices are the same, then you can combine the two radicals by taking what's under the numerator and under the denominator and dividing under one radical. And sometimes that helps us to simplify our radical expressions. So let's take a look at these two examples down here and see how we can use the division property of radicals to help us simplify this expression. So we notice that the index here is a cube root and the index here is a cube root. So we can combine these two under one radical and get 162 y to the fifth over 3y squared. Let's go ahead and simplify this fraction. And when we divide 3 into 162, we get 3 into 16 is 5, with 1 remaining. 3 into 12 is 4. So that divided in really well. How do we deal with dividing variables? Well, when we have the same variable, and they're both raised to the power and we're dividing, we subtract their exponents. So it should be y to the fifth minus 2, y to the 5 minus 2. So we're going to subtract these two exponents and we're going to get y cubed. And this is still all under the cube root. Now let's simplify this number right here. When we factor 54, we get 6 times 9. 9 factors nicely into 3 times 3, and 6 factors into 2 times 3. Oh, that's a 2. We're looking for groups of 3, so we can go ahead and pull this group of 3 out. We still have a 2 that needs to remain under our cube root. So now how about our 3's? We have an exponent of 3, and we're going to divide it by our index. 3 divided by 3 is 1 with a remainder of 0. So we can pull out one of those y's, and none of them remain under a radical. Because it's a cube root, we don't have to deal with putting absolute values around anything. So that is our answer. So let's move forward and take a look at our example 2. So here we're taking a square root and we have a square root. So according to our division property, we can combine that under one square root symbol. And when we do, let's go ahead and simplify our fraction underneath our square root. The first thing we're going to do is let's simplify our numbers. What goes into both of those? Well, we know 5 goes into both of those. So if we put 5 into 20, we get 4. And if we put 5 into 45, we get 9. Okay, so next thing, let's go ahead and deal with our variables here and simplify our variables. We know that when we divide variables with the same base, we subtract their exponents. So here we have an exponent of 1, and here we have an exponent of 1. When we simplify our variables, 1 minus 2 is a negative 1, and 1 minus 2 is a negative 1. Let's go ahead and fix our negatives because we really shouldn't have any negatives under a radical, or we shouldn't really have any negatives in our answer to begin with. So both of those variables are going to move to the bottom of our fraction here. So now that this fraction is simplified, let's go ahead and split it back up into two fractions, or a numerator and a denominator, because now I can go ahead and simplify what I have. I know what the square root of 4 is. It is just 2. And I know what the square root of 9 is. It is just 3. But how do I deal with square roots in my denominator? Because I'm not allowed to have any roots in my denominator. Well, you learned last year in geometry that the way to get rid of a square root is to multiply by the square root both the numerator and the denominator. And then the square root just goes away. So what we're going to do is we multiplied by the numerator and the denominator by the square root of AB, and we have this. So now let's take a look at our answer here. We have a square root. So we need to be careful about what we just pulled out. We need to put absolute values around everything that we pulled out to make sure that we are taking the principal square root of both the numerator and the denominator. Let's go ahead and simplify what's in our absolute values. We know that 2 is always positive, so we can pull it out because no matter what, it will remain positive. 3 is always positive, so we're going to pull that out. But how about our a and b? The exponents for a and b are odd exponents, so they must stay in our absolute value. And here is our answer.